Good morning, students. Today we will learn a very important topic in chemistry, that is types of chemical reactions. Before learning types of chemical reactions, I will ask a simple question. What is a chemical reaction? Let's take an example. I am asking a simple question. When an iron is left open for a long time, what happens? Most of you will answer it rosts. The color of the iron will change to brownish. So this is a chemical change, and rusting is a chemical reaction. Rusting of iron is a chemical reaction. So what is a chemical reaction? A chemical reaction is a process in which one or more substances react to form new substances. This is a chemical reaction. The substances which react are known as the reactants, and the new substances formed are known as the products. And a chemical reaction will be represented in a symbolic form, and that symbolic equation is known as chemical equation. Let's go towards the types of chemical reactions. Mainly there are five types of chemical reactions. The first one is combination reaction. The second one is decomposition reaction. The third one is displacement reaction. The fourth one is double displacement reaction. And the last one is redox reaction. Let's study them one by one. Starts with combination reaction. From the word combination, what is the meaning of the word combination? The meaning of the word combination is some things will combine, some substances will combine. So the definition of combination reaction is two or more substances combine to form a new substance, a product. That is a combination reaction. The general reaction is A plus B gives rise to AB. Since a new product is synthesized, that's why the combination reaction is otherwise called as synthesis reaction. A very easy example is N2 nitrogen plus 3H2 hydrogen gives rise to 2NH3. Nitrogen and hydrogen combine to form ammonia. This is an example of synthesis or combination reaction. The second one is decomposition reaction. From the word decompose, the meaning of the word decompose is breakdown. Something will break down. The breaking down of a compound to form simpler substances takes place in this reaction. So the definition is when a single compound or a single reactant breaks down to form simpler substances or simpler reactants, then the reaction is known as decomposition reaction. The general reaction is AB gives rise to A plus B. AB is the single compound. It will break down. It will break down with the help of heat, light or electricity to form A plus B. A is a simple product, B is another simple product. So this is decomposition reaction. A simple example is 2NH3 will decompose to form N2 plus 3H2. Okay, so this is a decomposition reaction. The third type of reaction is displacement reaction. Displace, the word displacement means something will displace another thing. A more reactive element will displace a less reactive element from its salt solution. That is the displacement reaction. Its general equation is AB plus C gives rise to SC plus B. Here C is the more reactive one. C displaces B from its salt solution AB to form SC plus B. This is single displacement because only one displacement occurred here. Example is Mg plus 2HCl, magnesium plus 2 hydrochloric acid. Here Mg displaces hydrogen from HCl to form MgCl2, magnesium chloride and hydrogen gas. This is an example of displacement reaction. Then the fourth type of chemical reaction is double displacement reaction. The word double displacement means displacement will occur two times. Double means two times. Double displacement reaction. In this reaction, there is exchange of ions between two compounds or two salts in the double displacement reaction. The general reaction is Ab plus Cd gives rise to Sc plus Bd. Here observe this example, Ab plus Cd gives rise to Sc plus Bd. Here Ab is a salt, consists of two ions, A plus B minus. Cd is a salt, consists of two ions, C plus D minus. Here these ions exchange each other to form Sc plus Bd. So two times displacement occurs here. So this is the example of double displacement reaction. A very simple example of double displacement is Na2S, sodium sulfate plus CaCl2, calcium chloride gives rise to CaS, calcium sulfide plus 2NaCl. Na plus ion, S2 minus ion, then Ca2 plus ion, Cl minus ion. These ions will exchange among themselves to form Ca2 plus ion with S2 minus ion and Na plus ion with Cl minus ion. This is an example of double displacement reaction. And then the last type of chemical reaction is redox reaction. The word redox comes from two words. If we will break down the word redox, then we will get red and ox. Red means reduction, ox means oxidation. So the reaction in which oxidation and reduction will occur simultaneously, that is known as redox reaction. So I have explained overall the meaning of the 5 types of reactions, just a brief introduction. Now we will study them one by one. The first one is combination reaction. Combination reaction is otherwise known as the synthesis reaction. As I said, the definition is when two or more substances will combine to form a single new substance. The general reaction is A plus B gives rise to AB. I have classified the combination reactions into 4 types. When the first one is one metal will combine with a non-metal, synthesis of binary salts. Second one is one non-metal will combine with another non-metal. The third one is one compound will combine with another compound. The fourth one is when one compound will combine with an element. Okay. So I have classified the combination reactions into 4 types. The first one is synthesis of binary salts, in which one metal will combine with another metal. Generally, these reactions involve heating a metal in presence of a reactive non-metal. Examples are when magnesium ribbon, when magnesium ribbon is heated in presence of oxygen, then a white colored substance that is magnesium oxide is formed with a bright flame. Most of you have seen this reaction in your schools. Burning of magnesium ribbon is a very famous example of combination reaction. So 2Mg plus O2 gives rise to 2MgO. Here magnesium is metal, oxygen is a non-metal. So metal plus non-metal combined to form 2MgO. MgO, magnesium oxide, is a binary salt. This is a white powdery ash. Another example is when iron fillings will combine with sulfur powder and then heated, they will form FeS, iron sulfide, which is a black solid. So this is also, iron is a metal, sulfur is a non-metal. So metal plus non-metal combined to form a binary salt FeS. Then another example is 2Na plus Cl2. Sodium is a metal, chlorine is a non-metal. So 2Na plus Cl2 gives rise to 2NaCl. NaCl is a salt, binary salt. Binary मतलब 2, bi मतलब 2. So NaCl is a binary salt. One ion is Na plus, another ion is Cl minus. Two ions are there. That's why it is a binary salt. Another example is 2Cu plus O2 gives rise to 2CuO. Copper is a metal, oxygen is a non-metal. So when copper turnings or copper foil are heated, then a black colored copper oxide is formed, CuO is formed. This is also a binary salt. Another example is 2Al, aluminum is heated with iron crystals. 2Al plus 3I2 gives rise to 2AlI3, which is purple color. So these are the examples of metal combined with non-metal to form a binary salt. Then the second type of combination reactions are when two non-metals combine. Very simple example. 2H2 plus O2 gives rise to 2H2O. Formation of water from hydrogen and oxygen. Here hydrogen and oxygen are the two non-metals. They combine. Another example is carbon plus oxygen gives rise to carbon dioxide. Carbon is a non-metal, oxygen is another non-metal. Here in this reaction, burning charcoal, that is carbon, in a deep flagellating spoon inside a gas jar or oxygen produces CO2, carbon dioxide gas. Then another example is phosphorus. P4 plus 5O2 gives rise to P4O10, phosphorus oxide. Okay. Phosphorus is of two types, white phosphorus, red phosphorus. So burning of white or red phosphorus in air produces thick white films of phosphorus pentoxide, that is P2O5. So this is an example of combination of two non-metals. The third type of combination reactions are when two compounds combine to form a new compound. Very simple example, when calcium oxide, that is quicklime, is added with water. Water is added with quicklime to form calcium hydroxide, slag lime. In this reaction, when we take a test tube, in the test tube we take the quicklime, calcium oxide, which is white color. Then we add water and then we will stir with a glass rod. Then after some time we will observe that when we will touch the test tube, we feel heat. Heat is generated in this reaction. So the reaction in which heat is generated, heat is released, is known as exothermic reaction. Release of heat takes place in exothermic reaction. So calcium oxide is a compound, water is another compound. They combine to form a new compound, that is calcium hydroxide, slag lime. Then another example is ammonia, NH3 plus HCl gives rise to NH4Cl. NH3 ammonia is a compound, HCl is another compound. They combine to form NH4Cl. White smoke is another compound. Then another example is SO2, sulfur dioxide plus water to form H2SO3, sulfurous acid. SO2 is a compound, water is a compound. They combine to form a new compound, H2SO3, sulfurous acid. The fourth type of combination reaction is when a compound is combined with an element. Generally, these are the combustion reactions. Takes place in presence of oxygen gas. The simple example, 2CO plus O2 is equal to 2CO2. Carbon monoxide in presence of oxygen forms carbon dioxide. Carbon monoxide is a compound, oxygen is an element, forms carbon dioxide, a new compound. Then another example is 2SO2, sulfur dioxide plus O2, oxygen in presence of P2O5 vanadium pentoxide catalyst forms 2SO3, sulfur trioxide. SO2 is a compound, O2 is an element. They form a new compound, SO3, sulfur trioxide. So these are the four types of examples of combination or synthesis reactions. Okay. Now we will learn about the second types of reactions, that is decomposition reactions. As I said earlier, decomposition reactions are fundamental chemical processes where a single reactant, a single substance breaks down into two or more simpler products. Usually, these reactions require energy. Mainly, these are endothermic reactions. The reactions which require energy, these are known as endothermic reactions. Energy in the form of heat, in the form of light, in the form of electricity. So, these are the decomposition reactions. The general equation was AB gives rise to A plus B. There are three types of decomposition reactions. The first one is thermal decomposition or thermolysis, which takes place in the presence of heat. The word thermal meaning heat. Okay. The second type of decomposition reaction is electrolytic decomposition or electrolysis. Takes place in the presence of electric current or electricity. Then the third type of chemical decomposition is photolytic decomposition or photolysis. Takes place in presence of light. Photo means light. Then the fourth type of decomposition reaction is catalytic decomposition, in which catalyst is added. What is catalyst? Catalyst is a substance which speed up a chemical reaction. So let's study them one by one. The first one is thermal decomposition or thermolysis. These reactions are initiated by heating a substance, often with a Bunsen burner. When a decomposition reaction takes place in presence of heat, heat is provided, then the reaction is known as thermal decomposition or thermolysis. The word thermo means heat, lysis means breakdown, breaking down or heating. So the word is thermolysis. Let's give some examples of thermal decomposition. The first one is thermal decomposition of calcium carbonate, which is known as limestone. The formula is CaCO3, calcium carbonate. Calcium carbonate is heated in the Bunsen burner to form calcium oxide quicklime, and carbon dioxide gas is released in this reaction. If we pass the carbon dioxide gas in lime water, then the lime water will turn milky. So this is the example of thermal decomposition. Lots of examples are there. Another example is when ferrous sulfate to FeSO4, ferrous sulfate is heated, then it will form Fe2O3 ferric oxide plus sulfur dioxide gas plus sulfur trioxide gas. This is an example of thermal decomposition, takes place by heating. Another example is decomposition of lead nitrate. When lead nitrate PbNO3 whole 2, PbNO3 whole 2, lead nitrate it is heated, then it will form lead oxide, which is of yellow color. Then nitrogen dioxide NO2 gas, which will give reddish brown fumes. Then oxygen gas. So these are the examples of thermal decomposition reactions takes place by heating. Then the second type is electrolytic decomposition or electrolysis. These reactions use electric current or electricity to break down compounds, usually in aqueous or molten state in presence of water. Aqueous means in presence of water. The examples are electrolysis of water. When water is electrolyzed to form hydrogen gas and oxygen gas. You can do this experiment in laboratory. You will take a battery and some salt and water. Then add salt with water, form salt solution. Then in the salt solution, two graphite electrodes are placed, and the two graphite electrodes will be connected with a battery. Then observe some time, see two gases will be released. One is hydrogen gas, another is oxygen gas. The hydrogen gas is identified when we take a candle near one electrode, then a pop sound will take place. See the electrolysis of water. In the image, there is hydrogen gas is produced at cathode and oxygen gas is produced at anode. See, at anode the reaction is 2H2O gives rise to O2 plus 4H plus 4 electron, and at cathode the reaction is 2H plus 2 electron gives rise to H2 gas. So at cathode hydrogen gas is released, and at anode oxygen gas is released. Cathode is the negative electrode, anode is the positive electrode. Okay, so this is the example of electrolytic decomposition reaction. Another example is when sodium chloride is electrolyzed to form sodium and chlorine. So 2NaCl in presence of electricity is equal to 2Na plus Cl2 gas. Another example is copper chloride. The aqueous solution of copper chloride is electrolyzed to form copper metal and chlorine gas. So these are the examples of electrolytic decomposition reactions. The third type of decomposition reaction is photolytic decomposition or photolysis. These reactions are initiated by light, specifically UV light. The word photo means light. Lysis means decomposition or breaking down. So these are the photolytic decomposition reactions. The two very important examples are photolytic decomposition of silver chloride and photolytic decomposition of silver bromide. In the photolytic decomposition of silver chloride, that is AgCl, the 2AgCl is decomposed in presence of sunlight to form 2Ag plus Cl2 gas, and the second one is 2AgBr is decomposed in presence of sunlight to form 2Ag plus Br2 gas. These two types of decomposition reactions are used in black and white photography. In these reactions, color change happens. That's why these two photo decomposition reactions are used in black and white photography. In the photo decomposition of silver chloride, the silver chloride is white in color. After photo decomposition, the white color turns to grayish black. The silver is grayish black in color as pure silver metal forms. So color change happens here. The white color of silver coated changes to grayish black color of silver. And in the photo decomposition of silver bromide, the silver bromide is pale yellow in color. The yellow color changes to grayish black of silver. So color change happens. Another photo decomposition example is decomposition of a silver nitrate. When silver nitrate decomposes, when it is exposed to light, means exposed to sunlight, then it forms silver, which is grayish black in color, with the formation of nitrogen dioxide gas and oxygen gas. So these are the examples of photolytic decomposition reactions which takes place because of light energy, because of absorption of light energy. Where light energy is absorbed, these are also examples of endothermic reactions. And the most important point is these are used in black and white photography. These are highly light sensitive and they are used to create photographic images. Okay. Then another type of decomposition reaction is catalytic decomposition. In this reaction, catalyst is added to lower the activation energy required. Catalyst is a substance which speed up the chemical reaction. So the example of catalytic decomposition is 2H2O2 hydrogen peroxide is decomposed in presence of catalyst MnO2 manganese dioxide to form 2H2O and O2. Here manganese dioxide MnO2 or Ki potassium hydrate can catalyze rapid decomposition of hydrogen peroxide, often used in elephant toothpaste demonstration. This is a very interesting chemical reaction which you can perform in the laboratory. So these are the types of decomposition reactions. Then another type of chemical reaction, the third type of chemical reaction is displacement reaction or single displacement reaction, commonly performed in laboratories to demonstrate the reactivity series of metals and non-metals. In the displacement reaction, as I said earlier, a more reactive element displaces a less reactive element from its compound or from its salt solution or acid. This is a displacement reaction. And which element is more reactive and which element is less reactive? How do we know? We know from the reactivity series. See the reactivity series. The series in your screen is the reactivity series. The topmost element is potassium, then sodium, then lithium, then barium, strontium, calcium, magnesium, aluminum, manganese, zinc, chromium, iron, cadmium, cobalt, nickel, tin, lead, then hydrogen. Hydrogen is taken as the reference. Below hydrogen, the elements are antimony, bismuth, copper, mercury, silver, gold, platinum. Platinum is highly unreactive. The bottommost element is platinum, which is highly unreactive, and the topmost element is potassium, which is highly reactive. This is the reactivity series. In this reactivity series, the elements above the reactivity series will displace the elements below them. Okay. For example, let's take an example. Let's take an example of zinc and copper. If we react zinc with copper sulfate, Zn plus CuSO4. See the reactivity series. Zinc is uh, zinc is below the manganese, copper is below hydrogen. So zinc is above, zinc is highly reactive. So zinc will displace copper zinc will displace copper from its salt solution. So it will form ZnSO4 plus Cu. Okay. So from the reactivity series, we will identify which element, which metal will displace which metal. Okay. The displacement reactions, I have classified the displacement reactions into generally four types. The first one is metal displacement reaction. When one metal will displace another metal from its salt solution, that is metal displacement reaction. The second one is hydrogen displacement reaction. When a metal displaces hydrogen from an acid, that is hydrogen displacement reaction. Then halogen displacement. Halogen means fluorine, chlorine, bromine, iodine. These are the halogens. So when this is also non-metal displacement. When one halogen or more reactive halogen will displace the less reactive halide. Okay. And the fourth one is double displacement. We will read it separately, double displacement. This is the fourth type of chemical reaction. So let's discuss the first metal displacement reaction. When one metal will displace another metal from its salt solution. The examples are Fe plus CuSO4 which is to FeSO4 plus Cu. Here iron is more reactive than copper because in the reactivity series C, iron is above the hydrogen and copper is below the hydrogen. Observe, iron is between chromium and cadmium, in the middle of chromium and cadmium, and copper is uh, above the mercury, below the hydrogen. So iron is more reactive, copper is less reactive. So iron will displace copper from its solution, copper sulfate solution, which is blue in color, to form iron sulfate and copper, Fe plus CuSO4 is equal to FeSO4 plus Cu. Here also color change happens. The color of copper sulfate is blue color. After displacement, the color changes to green because iron sulfate is formed. This is a very simple chemical reaction we can do in our laboratory. We will take the copper sulfate solution in a beaker. Then we will place an iron nail inside the copper sulfate solution. Then after 10 or 15 minutes, the color of the copper sulfate solution changes from blue to green, and above the iron nail, above the iron nail, a brownish layer, reddish brown layer is formed, which is of copper. Okay, so this is an example of metal displacement reaction. Another example is zinc plus copper sulfate. Zn plus CuSO4 gives rise to ZnSO4 plus Cu. Here also color change happens. The blue color of copper sulfate solution changes to colorless because zinc sulfate is formed. Another example is magnesium Mg plus CuSO4 gives rise to MgSO4 plus Cu. Magnesium plus copper sulfate gives rise to magnesium sulfate plus copper. Another example is copper plus silver nitrate to form copper nitrate, which is blue in color, plus silver. So these are the examples of metal displacement reactions. Second type of displacement reactions are hydrogen displacement reactions. In these reactions, active metals above hydrogen like zinc, iron, nickel, tin, lead, they can displace hydrogen from dilute acids like hydrochloric acid, dilute HCl, dilute H2SO4 to produce salt and hydrogen gas. Very simple example, Zn plus 2HCl. Zinc is above hydrogen. Okay, so zinc will displace hydrogen from dilute hydrochloric acid to form a salt zinc chloride and hydrogen gas is released. So Zn plus 2HCl gives rise to ZHCl2 plus H2. This is an example of hydrogen displacement reaction because hydrogen is displaced. Another example is magnesium plus 2HCl dilute gives rise to MgCl2 magnesium chloride plus H2 gas. Magnesium displaces hydrogen from dilute HCl to form magnesium chloride and hydrogen gas. Then another example, Fe plus H2SO4. Iron will displace hydrogen from dilute sulfuric acid to form FeSO4 iron sulfide plus hydrogen gas. Then another example is aluminum plus 6HCl. 2Al plus 6HCl gives rise to 2AlCl3 aluminum chloride plus 3 hydrogen gas. Aluminum displaces hydrogen from dilute HCl to form aluminum chloride and hydrogen gas. The third type of displacement reactions are halogen displacement reactions. Halogens are nonmetals, so we can call it as nonmetal displacement. In these reactions, more reactive halogens, generally they are in the top of the group 17 of the periodic table. They can displace less reactive halides from their compounds. See, there are mainly four halogens: fluorine, chlorine, bromine, iodine. The topmost is fluorine, below fluorine there is chlorine, below chlorine there is bromine, below bromine there is iodine. So more reactive halogens are fluorine, chlorine, and the less reactive halogens are bromine, iodine. So in the first example, Cl2 plus 2Ki, potassium iodide. Cl2 is more reactive than iodine, chlorine is more reactive than iodine, I2. So chlorine will displace iodine from potassium iodide to form potassium chloride plus iodine aqueous. So the reaction is Cl2 plus 2Ki, which is 2KCl, color is dark brown, plus iodine. Another example is Cl2 plus 2KBr. Obviously Cl2 is more reactive than bromine. So Cl2 displaces bromine from potassium bromide to form potassium chloride and bromine. Potassium bromide is colorless. The colorless solution is changed to orange or brown color of potassium chloride. So these are the examples of halogen displacement reactions. Then the fourth type of chemical reactions are double displacement reactions. Two times displacement occurs in these reactions, double displacement reactions. These reactions involve the exchange of ions. Here in the double displacement reactions, generally we take two salt solutions in which the exchange of ions takes place. The simple example is barium chloride plus sodium sulfate, BaCl2 plus Na2SO4 gives rise to BaSO4 plus 2NaCl. See, in barium chloride there are two types of ions, Ba2 plus ions, Cl minus ions, and in sodium sulfate there are two types of ions, Na plus ions and SO4 2 minus ions, sodium ions and sulfate ions, and these ions exchange with each other for barium sulfate. See, the sulfate ion combines with barium, and the chloride ion combines with sodium to form barium sulfate and sodium chloride. So this is an example of double displacement reaction. Generally, the double displacement reactions are of two types. One is precipitation reaction, another is neutralization reaction or acid-base reaction. In the precipitation reaction, formation of a precipitate or insoluble solid takes place. The reaction in which a precipitate is formed or an insoluble solid is formed, that is known as precipitation reaction. This is an example of double displacement reaction. The simple example, there are the four examples are given here. The first example is, I have already said earlier, when barium chloride is reacted with sodium sulfate. to form barium sulfate, which is a white precipitate, plus sodium chloride. This is an example of precipitation reaction because a white precipitate of barium sulfate is formed. Another example is AgNO3, silver nitrate, reacts with NaCl, sodium chloride, to form AgCl. The white precipitate is formed plus NaNO3. Another example is CuSO4, copper sulfate, reacts with NaOH, sodium hydroxide, to form CuOH whole 2, copper hydroxide, blue precipitate, plus sodium sulfate. The last example is lead nitrate, PbNO3 whole 2. Lead nitrate reacts with potassium iodide to form lead iodide yellow precipitate plus potassium nitrate. So these are the examples of precipitation reactions because in these reactions a precipitate is formed. Also color change occurs. And the second type of double displacement reactions are neutralization reactions, which you have read in previous classes also. Neutralization means acid-base reaction. An acid reacts with a base to form salt and water. Very simple example is hydrochloric acid reacts with sodium hydroxide. NaOH plus HCl gives rise to NaCl, sodium chloride plus water. This is an example of neutralization reaction. In this reaction also exchange of ion takes place. In HCl there are two ions, H plus Cl minus. In NaOH there are two ions, Na plus and OH minus. The ions are exchanged. The H plus ion combines with OH minus ion to form water, and the Na plus ion combines with Cl minus ion to form NaCl. So this is an example of double displacement reaction. Another example of neutralization reaction is when NaOH reacts with H2SO4 sulfuric acid, then it will form sodium sulfate Na2SO4 and water. Or another example we can say when potassium hydroxide KOH will react with HCl hydrochloric acid, then it will form KCl potassium chloride and water. So there are a lot of examples of neutralization reactions. So these are the four types of chemical reactions. One is the first one we read combination or synthesis. Second one we read decomposition or analysis. Three types of decomposition we read. The first one is thermal decomposition, then electrolytic decomposition, then photolytic decomposition. The third one we read displacement, single displacement. Fourth one is double displacement. The fifth type of chemical reaction is redox reaction. Redox means oxidation and reduction. Okay. In the next class, we will read about redox reaction. Okay.